time we were in class, I give a little bit of extra credit for the students who get an A, B, or C on that practice test. So, so there's two reasons to work the practice test. All right, any other questions? Thanks, Reed, for pointing that out to me. I will fix that when I get back to my office later on today. Any other questions that you guys have? Zoom or none? Good? All right, so let's go ahead then and let's get started in section 3.1. Again, I'm not going to review with you what the video said. Again, videos are not negotiable, okay? Videos are things that you need to have done by the time you walk into the door. Any questions that you have from the videos that I gave you? Any questions? All right, so then let's just go ahead and start right in on examples. I have to get 3.1 done today. I'd also like to get a good bit done in 3.2 because I am 1 day behind. So let's, we'll keep ourselves moving, but as always, if you have a question about something, stop me. I'm not so busy that I can't stop for questions. All right, so we're looking here at example number 1. Sorry I had to use the caret, but with a 57th power and a 19th power, it would not do a superscript for me on my iPad. So, so let's talk about I raised to the 57th power, okay? Now, you guys, in the video, you were given a pattern of numbers that repeats itself over and over and over and over again. And I actually gave you a little wheel to look at, okay? Now, the pattern, if you remember, begins with I. Oh, hang on. It begins with I. What's the next piece of the pattern? Look back at your notes. What's the next piece of the pattern? -1, all right? So we've got I is the first piece. Well, hang on just a second, having a little bit of technical difficulty. Might have to disconnect my pencil. There we go. All right, so I is the first piece of the pattern, and then we go to -1. What's the third piece of my pattern? -I, and then what's the fourth piece of the pattern? 1, okay? Now, here's the way that I look at this, okay? I get all excited because I get to cheer for my favorite math concept. Not really, but, so we've got I won, woohoo, I won. But the two negatives have to be the guys in the middle, okay? So that'll help you to remember what the pattern is. I won, with the negatives in the two center pieces. All right, so what we're looking for, always go for multiples of 4. You guys remember what multiples of 4 are? 4, what's the next one? 8, and then 12. Okay, we've got one person participating. Come on, Zoomers, what's after 12? 16, and then 20, and 24, and blah, 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 right? So we're looking for multiples of 4. Okay, so if we're looking for multiples of 4, find the closest multiple of 4 that gets you near 57. I mean, 24 is a multiple of 4, but it's a little too far away. So what's a multiple of 4? You can use your calculator if you want to. What's a multiple of 4 that gets you near 57? 56. Okay, 52, but 56 is closer, right? Is there another one? What about the one on the other side? 60, right? Yes, it's 57. So we've got either 56 or we have 60. Both of those are multiples of 4. Okay, so what we're going to say then is that in our pattern, all multiples of 4 land on the 1. All multiples of 4 land on the 1. And then what you're going to do is you're just going to count from there to get to the number you want. So if that multiple of 4 lands on the 1, so let's go with the 67 for a minute. So here's our I don't know what I just said, I to the 56th power, because that's my multiple of 4. Okay, so this is a multiple of 4, I to the 56th power. Well, how do I get to 57? Go back to the beginning and start counting there. Here would be 57, here would be 58, 59, etc. Okay, so if this guy is 56, go back to the beginning to get my 57th power. So I know then that I to the 57th is the same thing as I. Now, maybe you didn't like the 57, maybe you wanted to camp out on the 60, and that's fine. So let's say you were thinking, hey, my closest multiple of 4 is 60. Well, how do I get to 57 from 60? Well, I got to count backwards. So if this is 60, go backwards. This guy is 59, 58, 57, and I still land in the same place. No, I never said that you couldn't go over. I just said go find a close multiple, and it could be one on either side. Okay, so yeah, it doesn't matter if you go over or not. Okay, good question. I mean,
you'll get the same thing.
Absolutely, absolutely. Yep. Correct. Exactly. Exactly. All right. So either way, then I'm going to get I. Okay. So then let's go to example 2 here. What's a close multiple of 4 to the number 19? 20. Okay. So again, 20 is going to be my multiple of 4. So here's where my 20 is. So then how do I get to 19? Go 1 backwards. Go 1 backwards. So that means that I to the 19th power is the same thing as negative I. Now, what this means to us is that anytime you've got I's in a question, anytime you have I's in your answer, your I's should never, ever have a power on them in your final answer. Your I's should never have a power on your final answer, okay? Because all of my I's can be simplified to one of these 4 things in my pattern, and none of those has a power, okay? So all of your I's must be simplified. You should never give me a final answer that has an I with a power on it, okay? All right, so let's keep on going. All right, so do you guys remember what the standard way to write a complex number is? Very good, A plus BI. Okay, and this question is asking for the real part or the imaginary part. In my little standard form, what is the real part? A, and what's the imaginary part? Is it B or is it BI? It's only B. It's only B. If you forgot that, maybe go back and look at that part of the video, okay? The imaginary part is only the B part. Okay, so as we look at example number 3, what is the real part? Negative 8. What's the imaginary part? 4. Just 4. Okay. The I tells me it's the imaginary part, but it's not part of my imaginary part. I don't know if that makes sense. Okay. Here, what's the real part? 0. Because this is the same thing as 0 plus 3i. Or, yeah. What's the imaginary part? 3. Okay. Not too bad.
I was like so confused when I watched the video.
Oh, really? So I love that you said that, Jacob, because it is students who go back and rewatch videos after the lesson, their understanding level goes up immensely.
Yeah, it confused the crap out of me when I was doing the practice.
But on the other side, if you don't watch them before class, you're also going to be really lost. Okay, so you can't throw one out or the other. It's really a very good thing. Well, you have to watch them before class because you got to have the notes filled out. It's good to watch them after class because it's going to raise your understanding level. Okay, now when you watch them after class, put the speed up a little bit. You've already seen it once, so put the speed up a little bit if you don't need it to drag on. They're not that long, right? But you could put the speed up all the way up to 2. Okay, so let's just do some simplifying here. I gave you a list of rules. What was the first rule that I gave you when you're dealing with roots, when you're dealing with square roots? Always, 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 always deal with the negative first. Okay? So right now, I see that I have a square root of a negative. I don't even care about the 169 right now. All I care about is the negative. What is the square root of a negative? Really what should happen here is we should all be sounding like we're voting. Okay? So what's the square root of a negative? Everybody says I. Okay? So I know that the square root of the negative piece is going to be I. Now, let's go look at the square root of the 169 piece. It's going to be 13. So we have times 13.
Can you do just 13 I?
That was going to be my next question to you. So can I rewrite that in a way that just feels better? 13i? Absolutely.
So always square root is I. Right?
No,
A negative.
the square root of a negative is I. Mm-hmm.
Because
Did I do what?
Like, did you perhaps see a calculator? Because I literally had it in the test and I haven't seen it since.
Mm-mm.
I don't know if somebody like to snatch it up.
No, and I looked around right before I left. Have you gone back over there to check?
Yeah, I might have that in here. So.
Yeah, sorry.
I think everything about look back. But I don't remember if I put it in there or not.
Gotcha. Yeah, I did look around the room before I left because I had to put all those desks and chairs back where they belonged, the ones that I moved, and I didn't see it. So, all right, so let's look at number 96. Number 6. Okay, what's rule number 1? Deal with the square root of a negative.
Negative I.
Okay, so deal with the square root of a negative. So just the square root of the negative piece, just this piece right here. What is the square root of a negative? I. Now, what do you have out in front that you haven't touched yet? A negative, bring it down. You haven't messed with it. You can't just like throw it out for the fun of it. Okay. And then do you know the square root of 95? Is that as nice as the square root of 169 was? It isn't. It isn't. So for now, can you tell me, 95 is 5 times what? 19. You got a calculator there in front of you. 19? Okay. So the thing is 5 times 19, both of those are prime numbers. You can't do anything with either one of those. So the square root of 95, you ready for this? Here's a mind-blowing statement for today. The square root of 95 is the square root of 95. I know. Let it blow your mind. Yep. Okay. And by the way, there's nothing else I can do with this. Okay. Now I do want to draw your attention to the directions, because the directions say I'm supposed to write in standard form. And I haven't done that yet. Okay. Well, I have, but I haven't. If I were to take example number 5 and write it in a proper standard form, what is it that I would need to tack onto it? 0 plus, where I have an actual A plus BI. Okay, and then if I were to take the next example and I would turn it into standard form, what would that look like? 0 minus I root 95. Now, I gotta ask you something. Dylan asked me for number 5, can we please put the 13 in front of the I? How come I haven't taken it on example 6? Why didn't I put the I behind the number on example 6?
It's a different.
No, it's still multiplying. 13 times I times 13, I times the root 95 times I, still multiplying.
Put it on the 5, then it would be 95 minus 1 I instead of.
No, it wouldn't. It would still be times. It would still be times. What'd you say, Justin?
Feels right.
It feels right?
It looks right.
It looks right.
It would maybe look like the odds.
Bingo, Jacob.
That's
You run in, you have a risky little business going if you put that I behind a root. Let me show you what I mean. You don't have to write this down. This is the same thing as a negative square root of 95 times I. Those two are the same thing. That is totally legal. I'm totally fine with that as an answer. But what's risky is if you get a little sloppy and that I starts to look as though it is under the root, this has now turned into a problem. This is no longer the same thing as the line above it. Okay, so when it comes to roots and I's, I typically always put the I outside the root in front so that nobody ever gets confused as to how I was writing it. Okay, so that's why I've done what I've done. Okay, let's move on. Wow, okay, so example 7 and 8. Okay, so there was some shifting that went on in my last update and I did not fix that. The first one, the negative 11 one is example 7. Okay, so let's take this one at a time. What's rule number 1? Deal with the negs first. And when we say this is the negatives inside the square root. So I want to just deal with the negative on the inside of the square root. What is the square root of a negative? I. Okay. Now, let's talk about all the stuff I haven't touched yet. What about the stuff after the I? What's after the I that I haven't touched? No, I already dealt with the negative on the 24. The square root of 24. Okay, that guy's still in the square root. I haven't touched him yet. Okay. What about all the stuff in front of the I that I haven't messed with yet? There's a negative. What else? And a negative 11. So I have a negative 11 minus I times the square root of 24. All right. What are two numbers that will multiply together to give you 24? Okay. What'd you say? 4 and 6. 4 and 6. What's another pair?
2 and 12.
2 and 12. And then there's another pair. One more pair. 3 times 8. Okay, now, of all 3 of those pairs, I want the pair that has a beautiful square root in it. The one with a 4, right? 8 and 3, neither of those is a perfect square. 2 and 12, neither of those is a perfect square. But with 4 and 6, the 4 is a perfect square. So I want to be thinking of this as 4 times 6. And then I can split them up. So what's the square root of 4? 2, and what's the square root of 6? We don't know, so say it's the square root of 6, right? Because there's no perfect squares inside of that guy. 2 square root of 6, okay? Now, but you've got an I there, okay? So let's just deal only with this second piece here, the second term. So I've got an I. What's the number that I now have on the outside? A 2. So I have a 2 and an I outside. Okay. Would you rather write I2 or 2I outside? 2I is the prettier. So we've got a 2I outside and we have our root 6 that still has to stay inside. The 2 came from the square root of 4. Now what's all the other stuff that I haven't messed with yet? A negative, 11, and a minus. All right. Now, can I add or subtract these two terms? Why not?
They're not like terms.
Yeah, they're not like terms. They're not like terms. You cannot add and subtract things that are unlike. So this is done, and it's in standard form because it's an A plus BI form. All right, let's look at, how about you guys do this example here, example 8. Okay, what's rule number 1? Negatives first. So what's the square root of a negative? I, and then I have a square root of 16 left over, right? Okay, what's out in front that I haven't messed with yet? Another I, and this is being multiplied. What is I times I? I squared. And what is the square root of 16? 4. Now, remember me telling you that when it comes to your answer, you're never allowed to have a power on your I in the answer. Do you have a power on the I right now? Yeah, what's I squared the same thing as? This is from the video, the very first part of the video. It's -1. I squared is the same thing as -1. So this guy is going to turn into a -1. And -1 times 4 is? -4. Yep. Does that make sense? Okay. So that one would be plus 0I in standard form. To be honest, when there's a 0.
But is that right? That's -4.
When there's a 0 for either the A part or the B part, I'm fine with you just giving the other piece. All right, rule number 9, or exercise number 9. What's rule number 1? Negative first. Okay, so then what's the square root of a negative for the first guy? I times what's the leftovers? Square root of 5. Okay, times what's the square root? Yep, I for the next piece, and then times square root of 15. Now remember, all of this is multiplying, right? It's an I times a root 5 times an I times a root negative or root 15. Okay, so when it comes to multiplying, I'm allowed to trade the order around. That's totally legal. So if I'm trading the order, what's I times I? I squared. Okay, we'll deal with that in a minute. And then on the inside, you could say that 5 times 15 is 75, but don't. But don't. Okay? Instead of putting them together to make a big number, kind of like up here on, let's see, this example, we took 24 and we broke it into smaller numbers. That's the better option. So take your 5 and your 15. So here's my 5. How can 15 break up?
3 and 5.
Yeah, 3 and 5. I'm going to write it as 5 and 3. Okay, now look on the inside. You've got a 5 times 5. What is a 5 times 5? 25. And the square root of 25 is 5. Yeah, so this piece here is going to turn into a 5. Okay, and I never had to deal with a big number like 75. Right? You can. It's just a little bit more difficult, in my opinion. Okay, all right, so I've got, oops, try that again. Okay, so what is the I squared going to turn into? -1. And then what did the square root of 25 turn into? 5. And what about the square root of 3? Square root of 3, because I don't know that guy. Right? Okay, one more to clean it up. We've got a -5 root 3. If you had to take it one more step and put it in standard form, what would you tack onto that? Plus 0i. This is the real piece, and the imaginary piece would be the 0i. Okay? All right, what's rule number 1? Negatives first. So what about the guy on top? What's that going to become? Good, I square root of 70. Now, with the 70 part, well, we'll leave it alone for right now. And on bottom? I square root of 7. I keep forgetting to mention rules number 2 and 3 because those are pretty important. Okay, what is, you keep telling me what rule 1 is. What's rule 2? Exactly. I'm allowed to multiply and divide insides and insides, outsides and outsides, but never insides times outsides. Can I direct your attention back to the last example? Did you notice how the 2 outsides, the 2 i's we multiplied together, and the 2 insides, the 5 and the 15, we multiplied those together? Yeah, that's following rule number 2. So let's do the same thing on this one. Let's divide the outsides. What's I divided by I?
1.
It's just 1, right? Just like 3 divided by 3, 9 divided by 9, 27 divided by 27. Okay, if you've got a top and a bottom of a fraction that's identical, it's 1. And then I'm also allowed to divide the insides. Now, don't go thinking that when I divide the insides, it can magically jump outside. When I divide insides, it stays inside. Just like over here, when I multiplied insides, it stayed inside. Okay, so I'm dividing insides. Keep it on the inside. When you divide those insides, what do you get? 10. Oh, well, 10 doesn't break down any further because there's no perfect squares inside of 10. 2 times 5. So 1 times the square root of 10, I don't need that 1. Plus 0i if you're going to make it into standard form. Okay. All right, let's see here. Let's do a little bit of adding, subtracting. What's rule number 3? Because we haven't dealt with this rule yet. Like terms. Okay, always like terms. I've mentioned it, I just didn't call it rule number 3. So add and subtract like terms. Do you see here how I have 2 complex numbers? So there's 2 real parts and there's 2 imaginary parts. So combine your real parts, combine your imaginary parts. When you combine the real parts, what are you combining? 4 and 2, a positive 4 plus a positive 2. Okay, what do you get? 6. And when you combine your imaginary parts, -1 plus or minus? Yeah, -1 plus, yeah. And so what is -1i plus 5i? So plus 4i. It's already in standard form, it's done. Don't combine them, they're not like terms. Okay, let's go to number 12. What's wrong, Justin?
Would you say that second part again, the negative I plus 5i?
Negative I plus 5i. -1 plus 5.
Okay, because negative I is equal to negative 1.
Yes, my coefficient is a 1.
Okay,
It's not written, but it's there.
got you. Okay, got you.
Just like an x is the same thing as a 1x. Yep. All right, so number 12. All right, combine, don't say anything. Combine your real parts and write it down. Combine your imaginary parts, write it down. Make sure you're paying good attention to the signs. Combine your real parts, write it down. Combine your imaginary parts, write it down. When did we lose Reed? Did we lose Reed a long time ago?
Huh?
Reed, are you there?
Yeah.
Oh, there you are. You weren't showing up on my gallery feed. How you doing, Reed?
All right.
Cool, that was a close one, Reed. I almost counted you absent. I'm glad I said something. Okay, so when you combine your real parts, what numbers are you combining? Ooh, so is it a 9 and a -6 or is it a 9 and a +6?
Well, I wrote minus negative, so that's positive.
Good, good, good. So it's a 9 minus a negative, same as positive, 6. What's your real part? 15. Okay. When you combine your imaginary parts, what are the parts that you're combining for the imaginary pieces? -5i and -3i, right? Because there's a minus sign in there. Okay, so what is -5i, -3i? -8i. Okay.
Wait, so it's -5 minus 3i though?
-5i minus 3i.
Distribute the negative.
Oh, okay, so it turns into a positive. Okay, that confused me.
Wait, what turns into a positive?
So, oh wait, so it's -5i minus
3i.
Oh, okay. I thought we were adding a negative somewhere. Okay.
No.
Okay.
No, there's no magical negatives. Okay.
So it's still a +3.
What's that?
It's still a positive 3.
Well, it is a positive 3, but the minus sign in front of it makes it a negative 3. Okay, but that minus sign isn't only going to go to the 3, it also has to go to the negative 6. So that's how it was a minus negative 6, making it a plus 6.
Okay.
Since we're on a test, would you want us to write all of the workout?
No, not at this level. In Math 101, yes. Math 110, no. Okay, number 13. Real quick, what was my operation back on number 11? Addition. What was my operation on number 12? Subtraction. What is my operation on number 13? Multiplication. What do we use when we're multiplying two binomials? FOIL, which is distribution, but we're using foiling. Okay. Did we use foiling on number 11? No, because it's addition. Did we use foiling on number 12? No, because it's subtraction. The only time you use FOIL is when the operation is multiplying. Okay? So, first outer inner lasts. When you multiply the first, what do you get? Negative 8. All right? Outers, when you multiply the outers, again, watch your signs. Positive 4i. Okay? Somebody different. When you multiply your inners, what do you get? A positive 12i. And then let's take a look at the lasts. When you multiply the lasts together, what do you get?
Negative squared.
Yeah, negative 6i squared, because don't forget that an I times an I is a squared, an I squared.
Would it be okay to write that as just a positive 6?
Okay, now I'm not done because I have like terms that can be combined. Okay, now Dylan just mentioned that negative 6i squared, this whole entire term, is going to turn into what? A positive 6 because of that I squared. Remember, I squared is the same as negative 1. So neg 6 times a neg 1 is a pos 6. All right, so now let's combine like terms. What are my real pieces combined?
Negative 2.
Yep, and what's that going to give me? Negative 2. And what are my imaginary pieces combined? Plus 16i. Okay.
What did we multiply exactly? So we did negative 2 times negative 2, which is a positive 4. How?
Do you know FOIL?
No, that confuses me.
We'll learn it. Okay, it might confuse you right this minute, but it will make sense if you will start to use it. Okay, so F means first, O means outers, I means inners, L means last. Okay, all right, so November, firsts. These are my firsts. So you multiply them together, negative 2 times 4 is a negative 8. All right, and then following FOIL, I'm going to go to the outers. Those are the outers. Those are guys on the outside, right? Positive 4i, right? And then I go to my inners. So that's how I got a positive 12i, because 3 times 4 is 12. Okay. And then I went to the lasts. Negative 6i squared.
Okay, yeah.
And then my I squared turned into a negative 1. Negative 6 times negative 1 became my positive 6. Okay? All right. Number 14. What's the operation? Same things. Multiplying. Okay? So firsts, multiply your firsts together. What do you get? All right. Negative 25. All right. Somebody different. The outers. What do you get when you multiply the two outers? Negative 5i. All right. The inners. How about somebody from Zoom? On the inners, what do I get when I multiply the inners?
Negative 5i.
Yep. And then finally, open game, anybody. Lasts, negative I times positive I.
Negative I squared.
negative I squared. Okay, now, what is just the I squared piece? A negative 1. And you've got a negative in front of that. So what's a negative negative 1? Yeah, so we're going to turn all of this into a plus 1. Combine your like terms. So what are your real pieces?
Negative 24.
When you combine them, it's going to be negative 24, right? And then what are your imaginary pieces when you combine them?
Negative 10i.
Negative 10i. Does that make sense?
Is there ever a time where you go beyond that at all? Like, is there anything you could go beyond?
In Math 111, we will take imaginary numbers and turn them into polar numbers, which deals with radius and thetas, angles. So can we go further than this? Absolutely. Are we going to in this class? No, we are not. All right, aren't you disappointed? Okay, so this one looks difficult, okay, which is why I put it in there, okay, because it's actually not as difficult as it appears to be. What's the operation? Multiply. So I'm still foiling, okay, so this is the same as the last two questions. So let's go to the firsts. Okay, so the square root of 2 times the square root of 2 is the square root of 4, but I'm not going to write the square root of 4. What is the square root of 4? 2. Okay, so there's my firsts. Okay. Let's do the other easy one. Outers and inners look nasty, so let's go all the way to the last. I'm not skipping the outers and the inners. I'm coming back to them. Okay, go all the way to the last because that's the other easy pair. So when you multiply your lasts together, what do you get? Negative 16i squared, right? So your negative times your positive is your negative. 4 times 4 is 16, I times I is I squared. Okay, so now let's deal with the ugly pieces, the outers and the inners. Okay, look at the outers. For the outers, notice that I'm multiplying a square root of 2 times a positive times a 4 times an I. It's all multiplying. Okay, so a square root of 2 times a positive times a 4 times an I. Tell me this first. Is it positive or negative? Positive. Okay, that deals with one of those pieces. And what's a good way to write, and by the way, you've already done this today, what's a good way to write the square root of 2 times a 4 times an I? 4i root 2. That is the outers multiplied together. That wasn't so bad. Okay, now let's go to the inners. For the inners, you're multiplying a negative, a 4, an I times a root 2. Absolutely.
Switch the sign.
What do you mean by switch?
Like it's not a
Minus 4.
Right, so now it's a negative, right? Okay, so there's my negative. Now multiply your 4 times your I times your root 2. What are you going to write down? Now look at those two middle terms. What do you notice about the two middle terms? They're exactly the same thing except what? One's positive, one's negative. Hey guys, when you have two identical numbers, one's positive, one's negative, what do they always reduce to? 0. These two zero each other out. Okay, now let's go take care of that I squared because we're not allowed to have that. So what does the whole last term become? Negative 16i squared is going to become a positive 16. Let's combine our real pieces. What do you get? 18. If you want to write plus 0i, be my guest. But you don't have to.
Can we have just done the complex conjugate?
Yes. Yes, absolutely. Okay, number 16. What's the order of ops say you got to do first here? Does distributing come before the power, or does the power come before distributing? Yeah, how do you know the power comes before distributing? What's distributing? sorry, what operation is distributing? Multiplication. Powers have to come before multiplying. Okay, so you have to work the square first. So this is going to be the same thing as negative 5i times 4 minus 3i times 4 minus 3i. Squaring is multiplying. Multiplying two binomials says I have to FOIL. Okay. So for those of you who right now, your brain is saying, well, Miss Roberts, can't I just pass out that square and make this a 16 minus 9i squared? Okay. Keep that in your mind. Let's see if you and I come up with the same answer. All right. I say we're going to FOIL. Okay. So negative 5i. What's firsts? 16. What's outers? No. Negative 12i. What's inners? Also negative 12i. Now, guys, I didn't write anything down. What's a negative 12i and a negative 12i? Negative 24i. I'm going to just write that down. So that takes care of my first, my outers, my inners. What's my lasts? Say that. Can you say it again?
9i squared.
What kind of 9i squared? Okay, positive 9i squared. What is that whole term going to turn into? That positive 9i squared.
Negative
It's
9.
going to turn into a negative 9. Okay, so we're working in the group. That's what order of ops say first. That negative 5i, I'm still ignoring that. In the group, combine your like terms. What do you get? 7 minus 24i. Oh, but wait, there's more. Now I can distribute because I've taken care of the square. By the way, for those of you who were thinking that 4 minus 3i quantity squared was the same thing as 16 plus 9i squared, was it? No, it was not. It's 7 minus 24i. That is not the same thing. You must FOIL. Squaring a binomial is FOILing. Okay. Okay, so let's go ahead and take our negative 5i. Let's pass it out. When you take it to the first term, what does it become? Negative 35i. Plus, what's 5i times 24i? What's 5 times 24? Should be 120. Yeah. So positive 120 I squared, because it's an I times an I. So that whole term is going to turn into a negative 120. All right, now I'm going to stop right here for just a minute. Would it be correct to write my answer as negative 35i minus 120? It's not in standard form. In standard form, your real part has to go before your imaginary part. So you need to trade them. It's going to be a negative 120 minus 35i.
Is that called the commutative property?
Commutative property says I'm allowed to trade the order. Yep. Okay. 17, I think I gave a video on. I'm going to do the harder one, 18. Now, for this guy, you're going to need your dividing how-to. Okay, so you, on your video, you had a dividing how-to. Pull that out in your notes. You're going to need it. Okay, what did I call it exactly?
Conjugate and denominator.
It's called steps for dividing two complex, does that say numbers? Steps for dividing two complex numbers. Yes. Okay, so you need these steps. What is there, 4 steps? Okay, you need all 4 of these steps. So steps for dividing complex numbers. Okay, so what does step number 1 say to do? Find the conjugate of the denominator. Now this means that you had to pay attention to what the conjugate meant. So that was right up above the steps for dividing. First of all, what is the denominator on this question? 3 minus 2i. What is its conjugate? 3 plus 2i. You're only changing the sign of the imaginary piece. Wait, what did that how-to say to do? Find the what? Conjugate of the denominator? Oh, okay, we did that. 3 plus 2i. What does step 2 say to do? By what? By that conjugate, yeah? So we're going to multiply on top and on bottom. But what did you say the conjugate of the denominator was? 3 plus 2i. By the way, why is that legal? Why am I allowed to do that? It's the same as 1. What happens when you multiply by the number 1? You get the same thing back. Okay, so all I'm doing here is multiplying by the number 1. I'm not changing the value of this fraction. I'm just simplifying it. Okay, all right, on my how-to, what's it say to do next?
Multiply the fractions.
Multiply the two fractions. Now you remember when you're multiplying fractions, you got to multiply the tops, you got to multiply the bottoms. Okay, so let's take the two tops and let's multiply them. Oh, this is foiling. We just spent like however many questions foiling. Okay, so on top only, multiply the first. What do you get?
-36.
Yep. Multiply the outers. What's wrong, Justin? -12 times 3 is -36. You good?
Yeah.
Okay.
I thought we skipped the 5i and the 2i.
What?
Never mind.
You sure? Are you with me?
Yeah, I understand.
Okay, so I'm only foiling on top right now. Okay, so that was the first. For those of you on Zoom, you couldn't see Justin's face. He's looking at me like I grew 2 heads. So, okay, how about the outers? -24i. November, you're already getting comfortable with foiling. Nicely done. All right, what about the inners? -15i, and then the lasts.
-10i squared.
Good. Okay, down on bottom. We want to multiply on bottom as well. Okay, firsts on bottom. 9. Now look up here and don't write anything down. Okay, look at the outers. What do you get for the outers? A +6i. What do you get for the inners? A -6i. What happens with a +6i and a -6i? They're gonna zero each other out. By the way, that's what conjugates do. That's the whole purpose for multiplying by the conjugate. So the outers and the inners zero each other out. I'm not gonna write them down. Go ahead to the lasts. What do you get for the lasts?
-4i squared.
-4i squared. Now, let's take care of the I squareds. The I squared term on top, what is that term going to become? +10. And how about the one on bottom?
+4.
Yep, a +4. Now, let's go take care of everything, all the like terms on top and all the like terms on bottom. When you combine like terms on top, what do you get? No. Negative. I didn't hear a -26. Dylan, that's like your kink in your armor, is those negatives. -26. And what is the I piece going to give me? -39i. All over. Combine the bottom like terms, and what do you get? 13. I would so love to tell you you're finished, but you're not. Okay? For one thing, you can reduce. For another thing, this is not in standard form. Okay? Standard form has to be a separate real part and a separate imaginary part. Right now, everything's together. Okay? So what I like to say is you're going to share the love. That's a common denominator. Let's share that denominator with my two upper numerators. Okay? And you can do this in adding and subtracting. This does not work for multiplying and dividing, only for adding and subtracting. Okay? So you're going to make two separate fractions. This part can be done mentally, but I'll write it down. Negative 26 over 13 minus 39i over 13. So now my pieces are separate. This is more standard form, but my fractions still need to be reduced. Okay, so when you reduce the first fraction, what do you get? Negative 2 minus the second fraction. Negative, say it again. Yeah, negative 3i. That is standard form.
Why is it negative 26 minus 39i when it was two negative numbers for the negative 24 and negative 15? Why wasn't it positive?
Combine with terms.
When you combine like terms, so if you're playing a game and you're really far behind and you have a score of negative 24 and then you get 15 more questions wrong, you don't get a positive score. You just get a worse negative score.
Oh, I thought whenever you had two negative numbers and you were adding them together, it made a positive.
Mm-mm.
Wait. Oh, because the 24 is also a negative and that's the highest number. Is that right?
No, I don't know what you're talking about, but two negatives becoming a positive only occurs in multiplying and dividing.
Oh.
It doesn't occur in adding and subtracting.
I think I was thinking about multiplying them. Whoops.
All right, so I'm gonna go ahead. Oh, let me do number 19 for you. 17, like I say, I'm pretty sure there's a video on that. If not, follow the, you can try that one on your own. It's easier than the one I just worked. Negative powers. This is a Math 102 concept. What do negative powers make you do? Yeah, they have to move. If you have a negative power on top, it moves to the bottom and it becomes a positive power. If you have a negative power on bottom, it moves to the top and it becomes a positive power. So that this thing then is the same thing as what? No. 1 over I to the 15th power. How are you going to move it to the bottom without having a 1 there? Right? If you're going to move it to the bottom, you got to put something on top. So we'll have a 1 there. Okay, so then the next thing is remember me saying at the beginning of class, your final answer can never have an I with a power. Okay, so you're not done with this.
Negative I.
So let's be thinking here about your pattern. I won. What's a close multiple of 4 to the number 15? 16. Remember that my pattern is I won with the negatives in the middle. So my 16 is going to be here. So then what is I to the 15th power?
Negative I.
Negative I. So this is going to turn into 1 over negative I. Great. The problem is a simplified fraction requires no i's on bottom. A simplified fraction requires no i's on bottom. That was the whole problem with example 18. There were i's on bottom. That means it's not simplified. Okay? So let's follow our rules for division. What's the first rule for division? Conjugate. What is the conjugate of the denominator? Positive I. What am I supposed to do with that? Multiply it on top and on bottom. Why is that legal? Why am I allowed to do that? Yeah, I'm just multiplying by the number 1. Okay. So then what's the step number 3? No. Multiply your fractions. Multiply your fractions. If it were 2 binomials, November, then I would be foiling, but this is just a monomial times a monomial. Okay, so when you multiply the tops, what do you get? I. When you multiply the bottoms, what do you get? Negative I squared. Okay, wait a second. What's I squared?
Negative 1.
Negative 1. So what's a negative negative 1? So now it's just I. All right, any questions? All right, 3-2. What, do you guys remember what the embedded question was for section 3-1? I don't remember what it was.
Why is that legal?
Oh, and how many times have I asked that today? I did cover it. All right, so section 3-2, actually 3-2, 3-3, and 3-4 are all about the squaring parents. They're all about the squaring parents, okay? So a couple things that I gave you here. Let me tell you this, the completing the square review, this is really important. It's really important. If you had to learn completing the square math 1 and 2, if you forget how to do it, go back and watch that video again, get comfortable with it. And let me also say this, my students who are in my math 111 classes, because I have more than one, there's a whole entire chapter on nothing but completing the square, and it's completing the square on steroids. Okay, it's way harder than what we do here. So, but it's really important, especially if you're going further, but even short term, it's going to be on your test. Okay, a little bit longer term, it's going to be on your exam. But then if you have to take math 111, you have to be comfortable with completing the square. So you want to get comfortable with that. All right, so let's see here. I didn't highlight either of those. Okay, so this says that we should write in that P of x equals a times x minus h squared plus k. Hey, doesn't that kind of look familiar? Haven't we seen that before? Like, what does the inside tell us to do? This was just on your test. You know, like the one that you took on Thursday? What does the inside tell me to do?
Horizontal.
A horizontal what?
So horizontal shift.
Yeah, it's a horizontal. It tells me to move to the right H, doesn't it? What does the tell me to do? Go up. What does the A out front tell me to do? Yeah, what kind of a stretch? Vertical stretch, because remember, anything on the outside happens vertically, anything on the inside happens horizontally. Okay, so we've seen this before. This guy here, another way that you could say this is it's called vertex form. Vertex form. I'll explain why in a minute. Okay. And then I'm also asked to give the vertex, and I'm also asked to graph. So multiple things that I'm supposed to do here, and some of these things I'm pulling from section 2.6 that we did for the test. All right, so let's go ahead, first of all, my vertex form, yeah, I won't say that. Okay, so one thing that I need you to remember is that what's the letter in front of the first guy called? What's the letter called? Yeah? What's the letter of this guy called? B, and the letter of this guy? C, and you've seen that before as ax squared plus bx plus c. Okay? Now, notice that the a's, they both have an a. That's because that number is exactly the same. Okay, so if you know the A of one guy, you automatically know the A of the other guy. Okay, all right, so we're gonna follow then. Let me get rid of all this so that I can write here. We want to use our shortcut. So can you go back to your shortcut? In order to write this guy, I need to figure out what A is, I need to figure out what H is, and I need to figure out what K is. All right, those are the three things I've got to know to be able to write it like this, A, H, and K. All right, what did your shortcut tell you about finding H? Go back and look, it's there.
Negative 2a.
Negative B over 2a. Okay. So then we're going to take, we've got a negative here. What's my B value in this example? 2 over 2 times, what's my A value in this example? 1. Clean it up. What do you get when it cleans up? -1. Okay, so what are the 3 things I gotta know to be able to write this special form? A, H, and K. Okay, so far I have A and H. Now go back to your notes. How did it tell you to find K? Say it again. How to find K? It said plug and chug. Yeah. I mean, come on, think about it. If you, my vertex is always going to occur at HK. The H is the X piece. If I know X, how do I find Y? Plug and chug. So I found the X piece of the vertex. Let's go find the Y piece of the vertex by plugging and chugging. So this is going to be P of -1. -1 is that X piece that I just found. This is going to sound like what we did on our test, right? So -1 squared plus 2 times -1 minus 15. Just plug it in. You do the math for me. First term, second term. Okay. Combine them all, what do you get? -16. Okay. Oh, now wait a second. This is actually cool. You accidentally found a piece of your instructions. The vertex. Remember the vertex is HK? So what was my H piece that I found? -1. And what was the K piece I found? -16. Find the vertex. There it is. Okay. Now it also told me to find my standard form. Okay. So P of X is equal to, what was the A piece that I decided on? 1, right? But I don't need to write 1. So we've got 1 times X minus H. Okay, so I'm going to start you out. X, how am I going to write minus H? Yeah, that's going to be a +1 minus -1. It's a +1. Don't forget your square. Plus K. Bless you. How am I going to write plus K? -16. All right, I got a question for you. If that was on the test on Thursday, and I said, give me a description, what would you tell me to do with this squaring guy? Left 1 down 16. Wait, left 1 down 16. Isn't that what my vertex tells me to do? Go to the left 1 and go down 16? Oh, that's why this is called vertex form, because it shows me what my vertex is. Okay, so we're supposed to graph. Let's go left 1 and down 16. I don't know that I have 16 blocks here, so I'm going to go by 2s. Okay, so here's my left 1. 2, 4, 6, 8, 10, 12, 14, 16. I'm going to put my vertex. Now let's see if you remember what you need to about the squaring parent. Okay. Do you remember? This is on the library of functions. Remember, I told you that you had to memorize the graphs. Okay. So on the squaring parent, you remember this is the guy that is the parabola, the quadratic. Okay. So the origin was at 0, 0, right? And we went to the right 1, to the left 1, and up how far? No. What's 1 squared? 1. We went to the right 1, left 1, and up 1, because 1 squared is 1. Then we went back to the origin, and we went to the right 2, and we went to the left 2. How far up did we go?
4.
4, okay? So what I kept saying before the test was right 1, left 1, up 1, right 2, left 2, up 4. Because 1 squared is 1, 2 squared is 4. Are you following me? Okay, so that was what you were supposed to memorize on that piece of the library. Let's put it into practice on this guy. Okay? This guy, does he have any kind of a vertical stretch going on? No. So he's a normal width. He's just like Dad. The only thing that's different is that instead of changing his width or anything, all he did was shifted left 1 and down 16. So we go to our vertex, wherever it is, and we want to go to the right 1, to the left 1, and up how far? 1. Now be careful, because I did go by 2s. Okay, so if I go to the right 1, going up 1 is only going half a block, remember, because I went by 2s on my y-axis. And go to the left 1 and up 1. Okay, go back to that bottom piece, and now we're going to go right 2, left 2, up 4, because that's what Dad does. So if you go to the right 2, wait, how many blocks do I have to go up if I'm going to go up 4 units? Yeah, 2 blocks. And go to the left 2 and up 4 units, which is 2 blocks. And this gives me enough of a good width. You can go ahead and draw your parabola. Oh, but not with the eraser. Okay. So did I do everything? Write it in vertex form, give the vertex, and give the graph. I got all of those pieces. Okay. 7 minutes. Let's see what we can do for number 2. Okay, so what was the first piece that I needed to do? Can you go back? I'm supposed to get the vertex form, I'm supposed to find the vertex, and I'm supposed to graph. How did we do that? Found the H value first. Okay, so let's go get our H value. What's the formula for the H value? Negative B over 2A. Okay, so I've got my negative. What's my B value? 8 over 2 times, what's my A value? Negative 2. Did you answer it yourself? Okay. Now I have a negative divided by a negative. What's that going to become? Positive. And I have an 8 on top and a 4 on bottom. What is that going to become? Okay, so a positive 2. How do I go about finding my K value once I know my H value? Plug and chug. Okay, so P of 2 is going to be negative 2 times 2 squared plus 8 times 2 minus 9. Go ahead, Jacob.
On the bottom, so how did you get to?
How do I get this 2?
Yeah.
What's 8 divided by 4? That's how I got 2. No, it's all right. Does that make sense?
Yeah.
Okay. All right, so we're finding our K value. What's my first term going to become? Negative 8. Second term, somebody else? And then minus 9, I'll do that one. And so what is this, 16 minus 17? So negative 1? What's that? Very good. My vertex is going to be 2, negative 1. Can we go ahead and put that on our graph? We might as well. That's where we are right now. So 2, negative 1. I'll just go normal here. Here's 2. Here's negative 1. So there's my vertex. Okay. So I found my vertex. I also need to get my vertex form. Okay. So this is going to be P of X. What are the three pieces you got to have to be able to write your vertex form? The H and the K, so I have those. And what's the third piece? My A value. Look at your original equation. What's your A value? -2. So that's handed to you. You don't have to do any work to find your A value. Okay, so let's start writing my vertex equation. What's my A, did you say? -2 times, remember it's X minus H. So what will I write here? X minus 2 quantity squared, and then it's plus K minus 1. Okay. Now, because it's the second time around. That's what I love about math, Justin, is that the more times you do it, the more it makes sense. The first time around is like, I don't know, right? Right. But the more times you do it, the better. You know what? This is what I keep telling you to practice. Do your homework. Do it again. Because the more times you do it, the more it makes sense. Okay, I love that you said that. You totally just proved my point, so I appreciate that. And I didn't even pay him to do that. Okay, so let's finish this up. If we were back on the last test, we would know that we have to move right 1 and, move right 2 and down 1. We would know that. What would the guy out front tell you to do? Reflect it across the x-axis, Abigail, and what's the other piece that it will tell you? Vertical stretch by 2. Okay, so instead of opening up to the top, we've got to open down to the bottom. Okay, and we have to vertically stretch by 2. So let's come back. And remember, this is vertical, so I'm not making a change horizontally. I'm still moving right 1, left 1, and I'm still moving right 2, left 2. Okay, those are the same. Those are horizontal.
Left 2. No, right 2.
Right 2.
Right 2.
Okay. So we're going to go right 1 and left 1. What does dad do again? Right 1 and left 1. What does the parent do? Up 1. Okay, but we're going to move down. Okay, so if it was the parent, it would only go down 1. But we want to do double what the parent does. So we're going to go right 1, left 1, down 2. Parent would have gone right 2, left 2, down 4. We don't want to do what the parent does. We want to do double what the parent does. So we're still going to move right 2 and left 2. And now we're going to move down 8 from there. So 2, 4, 6, 8. Okay. We can get rid of these. And now you can kind of see this is a vertically stretched parabola. It's skinny. Okay, stretched from down.
I have a quick question.
Uh-huh.
Something I was confused about last time too. How do you look at the -2 in front of it and know that it's over the x-axis?
The negative.
Okay.
The negative
So-
tells me to reflect it over the x-axis.
So what if it was a positive?
It would be opening up instead of opening down.
Oh,
Yep. All right, folks. So we almost finished section 3.2. Please make sure that you take a look at these calculator things for section 3.2. I will expect you to understand and know how to do this when you get back to class on Thursday. I am not teaching you how to do this. The video will do that. Okay, so make sure you know how to do this on your calculator. See you Thursday.
I realized I left my calculator to a girl.
You remembered.
She just texted me, was like, "Are you